Good evening, popular astronomers. It is Vicky live from Anglesey and it is showtime. I was going to have a lovely calm show this evening, but my internet alert symbol is already showing in the corner of the screen. And I have just been doing some very heavy driving to Glen Miller after eating a triple portion of king prawn curry. So let's see how the evening goes. It has actually started raining, which affects our internet as well. So let me know how it's going. Are you there, popular astronomers? I can't see. We've got 18 viewers already. Give me some comments. Show me some love in the comments section. Good evening. How are you? Let me just have some plug the mug. Plug the mug. Plug in my mouth. Plug the mug. Plug the mug. Hi, Jim Roberts. You are first to comment. You win a free hello from me. Hello, Jim. Welcome to the show. Hello, David. So nice to have all you wonderful regulars along supporting me and not making me feel like I am so insular here on Anglesey. It is wonderful. Thank you. And even as we're coming out of lockdown, it's still very quiet around here. So I'm assuming a lot of us are still preferring the Herman's hermit life, which is why this show is such a wonderful lifeline to us all. Hello, Stephen Paul. I don't recognize your name, Stephen. Maybe you're a first-time viewer. Let me know. Hi, Liam, ISS man, ISS above man. We have got two guests on tonight who I think you're going to find really, really interesting. Oh, no. I've not done my vocal warm-ups and I can feel my throat getting tight. I'll just have to do my scales now. Do, ra, mi, fa, da. No, I'll save them. Maybe I just won't talk and give my voice a rest and communicate through the language of interpretive dance. Okay, so we have got a change to the original schedule tonight. One of our guests has dropped out, but in his place, we have got Neil deGrasse Tyson, Brian Cox. Oh, just inhaled his tinsel, and a holographic Carl Sagan live from the surface of the sun. This doesn't sound right. Cosmo has written the show tonight. I don't think that's a lie, Cosmo. We don't have any of those people on. Go back to the original script. Throw him into the corner until later. Okay, so tonight we have got no John Davies from the Initiative for Interstellar Studies or Sonia either. So we're two down. We might finish at 9 o'clock tonight, meaning I can go and circulate with my friends who are in the next room, which will be lovely. But we have got Eleni, my absolute space hero, with the news to blow your little space brain into smithereens. Okay. The topics on this show get ever more far-reaching and in-depth. This week, it's Bergita and Urs Ganse, siblings, and the coolest space siblings ever. I've had a chat with Urs earlier, and you won't believe what these two do over in Finland and Germany. It's hyper impressive. And they have written a book called The Spacefarer's Handbook. It is reviewed in the Pop Astro magazine, which I do believe is here. We'll talk about that later. Has this plopped through your letterbox yet? How far can we see? Not very far without my glasses, I tell you. Probably about 3 feet. Okay, and Urs and Bergita have written a book called The Spacefarer's Handbook, which offers insights into the scientific and practical dimension of space travel. So, if you are going to apply to ESA's astronaut program, be careful the way you get that. I'm completely sober, by the way. I don't drink. I'm just very excited to be here. If you're going to apply to ESA's astronaut program, you need the Spacefarer's Handbook written by this pair of siblings who are going to be coming on very shortly. Okay, so let's have a look. For some reason, I can only get Pop Astro Live on my... Okay, well, Liam is helping there. Hi to everyone. Wonderful. Hello, Paul. Oh, see, my instincts are correct. Stephen is a first-time viewer. So welcome to the show. It's great that you're contributing already. Hopefully you are a member of the society already, Stephen, but if not, we'll let you off. We like to say that new viewers, if you watch the show more than 3 times, it'd be wonderful if you could join the society. And at a blistering price of only £23 a year with this magazine every couple of months and lots of other goodies as well, it is excellent value. So, Madeline Dunn, the lady with the pussycat face, has renewed her SPA subs today. Well done. You'll barely notice that £23 dent in your account, but you will notice getting this beautiful, lovingly crafted by our members and volunteers magazine every 2 months. I'd say it's a fair trade. A couple of rounds of drinks in the pub, or this. Wonderful, wonderful. Okay, so guess what day it was last week? Do you remember? It was Solar Can Day. So our Solar Can, where's it gone? Gonna do this live on air now. Thank you for renewing your subscription, Madeline. This is a Solar Can solar camera, and I am now going to open it up and do live image processing and see whether we can get the image back. I've got a little system rigged up. So what we need to do, popular astronomers, is I need to turn off my monstrous big ring light because light damages the photographic paper. I'm going to get the can opener. I'm going to open it. And where's the can opener gone? There it is. Okay. So it's all going to go a little dark in here. It says that doing it by the light of a 60-watt bulb is usually sufficient. So for some, let's have a look at the comments coming in. Oh, I look haunted now. Oh, wow. It's really brought out my beautiful skin tones, hasn't it? Evening, everybody. I shall be popping out in and out whilst I pack and do tea. Where are you going, Sonia? Jim is wonderful. He says he believes the SPA mag is the best astronomy mag available. And the reason why is because we let you get your own pictures in it. Pack, I know, yeah, where's she going? Maybe she's going to the moon, Liam. That's the kind of thing that Sonia would like to do. Right, so I'm going to take... Oh, where's my phone? Right, okay. This is a solar can. It's been mounted on a stick in our backyard on the top of a shipping container overlooking a caravan park for 6 months. We put it up on Midwinter's Day. During that time, it has been making... the sun has been making traces on the photographic paper. And I am now going to get it out. I'm not going to scan it. I'm going to take a picture of it. Weekend away for... Wonderful, Sonia. Right, okay, here we go. Please don't let me break the can opener. It's a bit gritty, but wouldn't you be had you been on a stick by the seaside for 6 months? Let's have a look. Right, I'm going to turn my screen brightness down. So, so dark. Don't worry, this bit's only going to last for a moment, popular astronomers. So what we're going to do is I'm going to take the photographic paper out. Ooh, that's sharp. I've already had a big nettle sting today. I don't really want any more sharpness in my life. I need to lever that out with something. Excuse me while I look for an implement in the dark. It's going to have to be something off my makeup trolley. I can't see. I actually can't see. Does that feel... That feels like it might get something out. I'll use a mascara wand. So maybe I did that thing like when I'm lazily opening a tin of baked beans and didn't go all the way around and just put my fingers in it. And this is not what they do on Blue Peter, is it? Bear with me, callers. I haven't quite opened the can, but I do believe the results are going to be astonishing. And I can already see images on the photographic paper, which is good. Oh, come on. Right. Live on air. Solar photography. Oh, wow. Right. Okay. So we're going to jack that open. Here it comes. Oh, come on. Right. See, look how sharp that is. If you are over the age of 16, you'll definitely need an adult to help you with this. If you're over the age of 16, you'll need a child to help you with this. Patrick Moore. You see, Paul, and that is why we're such a diverse show. We feature mascara. Come on, all the way around now. I am asking for a hiding on my fingers here now. Trying to open a very raggedy can edge. If I've not got it in the next one, in the next pass. Oh, we've got it. Right. And then typical Vicky style, I haven't finished reading the instructions. I'm just winging this. So I do believe this lovely... It's quite well packed in there. Wow, the rain is really coming down now, and the rain affects our broadband. So, oh dear. I can't get this out. I've creased it. It's stuck. Might have to go over to the interview now while I meddle around with this. Let's put Bergita and Urs on so we're not watching me in the dark. Hello. Hi.
Hi, everyone. Hello.
Good evening. How are you both?
I'm great, but it's so beautiful over in Finland. Look at the sunshine. Amazing.
Oh, yes, because you're not in Finland, are you?
I'm in Germany, in southwestern Germany, on the border to France, and it's raining.
Oh, it's raining here as well. How are you both this evening?
Great. Thanks for having us. Great to meet all of you.
Yes, thank you very much. Our society members. Oh my gosh, I've really creased this up. Do you know I'm trying to remove some photograph? Oh, it's stuck in. It's held in. Oh, I didn't see that bit. It's got like a holder.
Vicky, how do you want to do this in space flight in zero gravity when you
I will not. Hey, listen, I went on some roller coasters a couple of years ago, all on my own, and I was so ill from them. And I know that being an astronaut is very much not for me. So I bail out already. But I hear Urs is applying for the ESA project.
Urs, do you hear us?
Can you hear us? Hello?
Hello.
Oh, my internet, I think, is a little bit on the laggy side. I'm going to try switching to the other connection.
Yes, okay. We did test that before, and I need to read the instructions today. So, Bergita, tell us, you have got an incredible job title. Tell us what you do.
Well, I don't know which job title you've read, but
all of them.
Well, I'm a physician and I do research in spaceflight. I have an ISS experiment and I do research in bed rest studies, which is something crazy I can explain to you if you like. So basically, ESA and NASA are putting people in bed with 6 degrees head down tilt to simulate space flights. And my research is on the musculoskeletal system in spaceflight. And I'm a university professor in a university in Germany now. I worked in the UK until February this year, but left because of the job, despite my love of the UK.
Oh, wow. So just rewinding back, thank you very much for your kind comment there, Jim. Just rewinding back, one of the most interesting things is that people get paid up to 38,000 euros to lie in bed for 2 months with tilted backwards.
That's correct. And they have muscle biopsies and blood taken on top of all of that. And they have to eat all the salad, everything they get. No way around it. They have to finish the whole plate. So think twice.
Wow. And what's people's mental state like through this incredible experiment?
Well, they'd be selected in a way that these guys only take the ones who are really stable, because I think most people would really get problems, including me. I guess I would get into trouble there because you're not allowed to get up at all. You need to have your shoulder touching the mattress at any time. You have to eat all the salad they give you. and you're not allowed to have visitors or friends coming over. So it's quite an isolation situation. I think I wouldn't really be able to cope, but lots of people are lining up for this, and I think many people really enjoy it because they can just watch all the TV shows they have ever wanted to watch. They can play all the games. They can just do whatever they want online, basically, while they're there, which is not typical for spaceflight because, when you leave Earth and you're in a distance, you won't be able to use the internet anymore. So it's an advantage of bed rest.
So obviously the number one killer question on everybody's lips is, when you're tilted backwards at 40 degrees, how do you go to the toilet?
Like people in the hospital, just with a bottle and a pan.
Okay.
That's part of where they get so much money because it's so annoying. I'm not into that, but yeah. People are lining up for these jobs, really. Last year it was 15,500 euros for 60 days in bed.
Wow. Oh my. Now, I'm sorry. I'm going to put my pinhole camera away until I get further instructions on how to do this, because I didn't read the correct instructions, and I'm going to turn my big light back on. So just bear with me. Urs, can you hear us?
Yes, I
Yay! Hi, Urs.
Thank you. The connection is now working much better.
Well, just bear with me.
I'm a bit far away from civilization here, 3 hours north of Helsinki by a lake in Finland. It's pretty bad, the internet.
That's a long way.
Yep.
That's a long way. Very good. I'm back now. I'm back. Panic over about the pinhole camera. Well, that was a real anticlimax, not knowing what to do with it. It was stuck inside. So hi, Urs. We had a little chat before, and so you two are exceptional space siblings, and your job is exceedingly cool as well. So you are a professor of space medicine, Bergita, is that right? What's your title?
No, innovative implant development. I also do space. I like to do space, and I mainly do space, but I earn my money with designing implants for orthopedic surgery.
That is amazing. Oh, well done for keeping us all moving. And Urs, what do you do then?
So I'm in the University of Helsinki as a researcher, and I'm doing big computer simulations of plasma flows near Earth. Finland, as you may imagine, is one of the countries that's on the forefront of research in northern lights, because they happen here, actually, north is right behind me. So when they happen here behind me. And so Finnish researchers have always been studying northern lights and then gone up from there, because northern lights happen when solar wind and plasma space hit the upper atmosphere. And then the question is, where do they come from and what are the processes that are causing them? And that's what we're researching. So I use big supercomputers and try to understand how plasma flows, solar wind, magnetic fields, and all that happen around Earth.
That's just so nice to hear those words. What an amazing job. It just sends me into bliss. So tell me what's at the forefront of Aurora research at the moment then.
Well, one of the most recent results that we did in our group was actually collaborating with some popular science, so like aurora watchers, people that look at the sky at night and take pictures, both in Finland and in Scotland, actually. And we've written a collaborative paper where we discovered a new form of northern lights that was never documented before, that people had seen both here in Finland and in Scotland, but nobody ever documented. So we did a catalog, and we took simultaneous observations from both sides of the North Sea and triangulated and found the structure size and so on. It's called the Dunes, and it was just recently published. That was the most recent thing. There's another group in Canada that just 1 year before discovered a new aurora form. We're a little bit competing with them. So right now we have the lead, but who knows what they're going to come up with next.
So what does a day in the life of somebody who studies the aurora look like?
Well, since I do computer simulations, mostly I sit in front of my computer cursor a lot when it doesn't work. So that's very similar to how everybody works nowadays in the pandemic. The difference is I'm sitting in the log cabin by a lake, so that's nice. But so I log into the big supercomputers in Finland and in Germany and in the UK as well. And I run simulations, and then I download a terabyte of data and find out that I did a typo somewhere, and then run them again. And eventually I get some nice animations looking at how plasma flows, and I analyze and write scientific papers and do research.
That is just so cool.
When there's
That is so cool. So I guess you get good aurora up there. I don't know what latitude Finland is on. Could you please educate me?
So Helsinki, which is the southernmost bit of Finland, is at 60 degrees. And I'm 3 hours north, so this is about 63.5 degrees. So that's very nice for aurora observations in the northern direction. And then, of course, Finland goes all the way up to the polar circle. So if you are in Lapland, in the northern bit of Finland, then you are very well situated right under it.
That is pretty cool. So I'm just having a look at the comments here. Liam is asking, sorry, we're jumping around a little bit. Okay. So Liam is our ISS man, and you should get hooked up. He's intrigued about the experiment. So it's on the neuromuscular electrical stimulation to enhance the exercise benefits for muscle functions during spaceflight.
That's right, Liam. Hi, and thank you for asking. So what we do is we try electrical stimulation of the muscles to see if that helps counteract the losses in muscle mass and muscle power or muscle strength in spaceflight. You know, when you're in weightlessness, you lose all the muscle power if you don't exercise, because nothing weighs anything. You can pull a whole space station up on one finger. And as you can't really exercise with weights, you need to find other ways to exercise. And currently, rubber bands are used, or under pressure cylinders where you pull out something out of the under pressure. That is an option, or those are options. Another option currently tested is human centrifugation, like spinning people and using rotational forces to generate something like gravity. But muscle-wise, we just discovered that that's really not enough. And it's just not enough to generate 1G at the center of mass or something, because it's like when you're in bed on Earth and you get up once a day for half an hour or so and you stand up, that will also not save your muscles. So what we've suggested 2 years ago when ESA had a call for ISS experiments is to test electrical muscle stimulation, as in the gym. A lot of people use this in the gym.
Oh, yeah.
Yeah, it's also being used for patients who are immobilized in bed. And it's also used for other purposes. Some people use it for fun purposes, but then not in the muscle context, but otherwise. So you put on electrodes on top of the muscle, and then the electricity will kind of go through the muscle, activate the neuromuscular junctions, and then make the muscle contract. And when it contracts, it exercises, it trains. It is not as efficient as proper exercise on Earth, but it's a really good way to counteract muscle losses, possibly in spaceflight. At least it's a good way to counteract them on Earth when people are in bed, and we think it's going to be a good solution, because astronauts currently have to train 2.5 hours daily. How many of you train for 2.5 hours daily? I don't.
Never. 2.5 hours weekly.
And that's just a pain in the ass. It's just so much time, and they could use their time better and more efficiently if we could cut it a little bit. And even if we could cut it by maybe, say, 15 minutes or so by using electrical stimulation, that would already be a really good success story. So we'll have 16 astronauts, 8 in the intervention group, 8 in the non-intervention group. We'll do pre, post, and in-flight experiments. So it's quite cool, actually, that they take blood for us. So they take blood by themselves, off themselves. They spin it, they freeze it, and then they bring it down, and we can have a look at what's inside when you have it.
I know Liam is so heavily into anything to do with the ISS, and I bet you've really enjoyed that one, haven't you, Liam? I bet that was like amazing for you. So the TV adverts where they're all you get a 6-pack from one of these little the electrical pads. Are they all going to come down looking like Hulk Hogan? With all like really
Urs already looks like Hulk Hogan.
Do they work? Do they work, those machines?
To a certain degree they do, but it's more efficient to do proper exercise in the gym yourself, to activate your own muscles with your own nerves. That's more efficient. So it's something you can do on top of your normal training to squeeze out those 2%. So if you're a super perfect elite athlete and you want to get those 2% to be able to defeat your enemies, then you can use it, but it's not really that. It's not really as efficient as advertisements promise.
That is great. So I'm just trying to fiddle with my camera setup here, and I don't want my microphone to fall off. So yeah, we've got a question. Does a lack of muscles? Hello, Adrian.
Hi, Adrian.
Hello. A lack of muscle stimulation due to being in space will be very dangerous for your heart. What about that?
Yeah, well, that's not the muscle stimulation as such. So the heart doesn't have to pump as hard, because you have a fluid shift going up. So the fluid from your legs that usually collects in your legs moves up in your body, and then you pee out 1.5 liters of water from your blood within the first 24 hours when you're in space. And when you've peed that out, you have less blood volume, and then the small blood vessels in the periphery of your body dilate, and that means your heart does not have to pump as hard anymore. And while your heart doesn't have to pump as hard anymore, it shrinks. It really shrinks physically. When you do ultrasound of the heart, you can see that it's smaller in space. And that's why they have to do endurance exercise, such as treadmill and cycle ergometries. You know, things you know from the gym. And yeah, that's another big topic in spaceflight. I'm a musculoskeletal researcher, though, so it's not my primary focus, but it's a really exciting topic, I think. It's also, there's a theory that people with heart problems will actually benefit from weightlessness because it's good for your heart. Isn't that exciting? And there's nobody with a heart disease has ever been to space, because usually they select super healthy people for spaceflight.
So Adrian then continues, question part 2. When you come back to Earth, is it a big shock to the heart? You've got a little walnut-sized heart that's suddenly got to swell up.
Well, it doesn't shrink as much, but it does shrink by maybe
So
I guess it's not just the heart, it's the whole cardiovascular system, right, Gita?
Yeah,
okay.
Yeah. And the thing is, it's not really a shock, but what you get is orthostasis. So that's a special word. It means that your blood drops in your legs because the pull of gravity will pull it down, and then you don't have enough blood for your head and your brain, and you will faint. And that's what you get to see a lot. A lot of astronauts actually faint when they give a talk or a speech or whatever it is about a day after spaceflight or so, and that lasts for a few days. So when you land, you need to drink a lot to fill it all up again.
That is pretty amazing. We've got a new viewer here, I think. Oh, maybe Sean's been on once or twice before. Hi, everyone. Great show. That's nice to know that, isn't it? Thank you very much. So, okay, then. So we'll come back to your areas of speciality in a minute. If you've got any questions about the Aurora or lying in bed for 2 months, these two are your people to ask. So now, ESA have extended their astronaut application process. Isn't it the first application process in 12 years? Maybe.
That's right.
It's a long time. Yeah.
The deadline just passed last Friday, unfortunately. So anybody who's
it's gone.
of applying now, you are just too late for that, unfortunately. All those viewers who have applied, good on you, you're in.
And you recommend that if they do go through the selection process, or if they are going through the selection process, to get a hold of a copy of your book, which is reviewed in the magazine here. Would you like to hold the book up? Let's have a look. I'll put you full screen, Urs. Hang on. Full screen. Hang on. How does it go? Full screen. Which one is it? It's, oh, wow. Where's the magic full screen button gone? Maybe just that. Oh, hang on. It's up there.
I guess the
solo layout. There it is. There it is.
Right,
let me get rid of the banner. So this is your wonderful new book that you've written together.
Yeah,
First, you need to move it up and down. Move it up and down.
Science and Life Beyond Earth. Your names. The publisher, and you can get it on all the usual bookstores. I mean, Amazon has it, Barnes Nobles has it, I think Waterstones has it. So the Spacefarer's Handbook, and it's kind of thick actually because we filled it with lots of stuff.
Wow, that's a very thick book.
It's not too expensive either. I think it's £19.90 or something like that for the
That's
printed
really
version,
good
for the ebook version.
That's really
and
good considering.
Lots of photographs, and pictures.
Let's have a look through it. Let's have a quick flick.
Okay.
If you open
me put my
the
laptop
book up.
a little bit down like this, so I have both hands. So we have. Well, what do we have? We have chapter 1, which tells you. First, we have a picture of us inside the Soyuz capsule, where
we can't really see.
That's it. Cool. Oh, it's little, isn't it? It's small.
All of us inside the Soyuz capsule in the astronaut training center, or former astronaut training center in Toulouse, where we've been sitting in one. Then the first chapter is a little bit about the history of spaceflight. We have some QR codes. We have information about if you want to be part of an astronaut selection, what do you need to do to be selected as an astronaut. Some mission, and then we have a chapter on building spacecraft that includes everything from what is the overall structure, to spacecraft hull, rocket engines, shapes of the re-entry capsules, and so on. So here's a nice diagram of what you put into your engines. Then chapter 3, let me flip forward to that, which is about how to steer a spacecraft, because that's not like obvious or intuitive at first glance. How do you do this in orbit if gravity pulls you down all the time? You can't just fly in straight lines. If you try to fly straight towards the space station, you will miss it. But this book tells you how, and we've been told we've done a pretty good job illustrating how to navigate in Earth orbit and how to navigate to other planets and how to get all the orbital transfers and docking correct and so on. So that's what this chapter is about. Then we go to Chapter 4, daylight. Really to the nitty-gritty funny details and the kind of things that you don't normally read or hear about in introductions about spaceflight. It's about how do you wash your clothes in space, or how often do you need to? How do you get mold on a space station surface? How do the sleeping bags look like? Then there's eating and drinking. Coffee in space. How do you cook coffee without gravity? Because if nothing pulls it through a filter, how do you do it?
How do they do it? Force it through? Yeah, I guess.
There are two methods. The old method, called the Expedition 13 method, that was invented a long time ago, is you put your coffee into a plastic mug, put some sieve on top to basically build something like a French press. And then you put it in a socket and spin it around. By spinning it around, you create artificial gravity. And that way you get your coffee compressed and you get nice coffee. But then the Italians recently, when Samantha Cristoforetti flew to the ISS the first time, they brought an espresso machine. And an espresso machine works with pressure, with compressed steam. So that works without gravity. Very nice coffee on the ISS.
Urs, I'm sorry, your internet is breaking up just a little bit. So we're just going to go over to Bergita. I know my internet is usually terrible when I do this show. So mine seems to be okay. So we'll just ask...
That's great, because you can continue with chapter 5.
Okay. Oh, yeah, there we go. Lovely. So we'll go over to Bergita for a minute. If you can answer the question, with your deep knowledge of spaceflight, what did you think of the film Gravity? Did you spot errors?
Yeah.
I've not seen it.
Yeah, I've seen it. It's fun to watch because of beautiful scenes, but there's a lot of crap in there. It's actually I show my students some examples I give a lecture series on space medicine in the university here, and we like to watch some scenes to demonstrate how wrong it all is. But it's actually fun that it's so wrong. So maybe Urs wants to talk about that, because from a physics perspective, it's just insanely wrong. While it looks good, it's fun to watch it.
What kind of mistakes are there, Urs?
It's all wrong in terms of orbital mechanics, because apparently the filmmakers just wanted to make sure we're in space. They didn't from one shot to the next, you see the Earth rotating this way, and then it rotates that way, and then it rotates this way. Then there's the ISS and the Chinese space station, which are not on the same orbit at all. They're crossing at like 30-degree angles, and the main actors just jump over from one to the other.
Do they?
The physicist, I say, is almost a slapstick movie, but it's still very nice because it's atmospherically nicely done, and the spacecraft interiors are quite accurately reproduced and so on. So, yeah,
good actors, very good actors.
Very good. So, Bergita, tell us a little bit more about. Now, I was chatting with Urs earlier, and he mentioned about how it's quite a small group of people do space medicine. What's that? Quite a small group of people do space medicine in the world. Like, what's that community like?
Yeah, it's a very diverse community with really fun people, I think. So many different backgrounds, and everybody's adding kind of their stuff. So lots of physicians, physiologists, sports scientists. I'm actually a physician and a physiologist, so I'm combining both of it. But also many engineers and physicists working in the field. And what I really like about it is the international issue, that people from all sorts of backgrounds collect in the field, and they come from all areas in the world. But while the community is so small, everyone knows one another or each other. So it's very exciting. We often meet at conferences, and then the community is so small that you know everyone who's doing it in Australia or Brazil or wherever in the world, and that's what I really like about it. So being so spread out, and we have we formed a space surgery association a year ago during COVID, and it's full of people from all around the world, and that's what I like about it so much. And we talk to Russians, we talk to Americans a lot, and to people from all continents, and I think there are not very many fields that are so small where people are spread out across the globe.
Oh, and so what advice would you have for somebody, not that anybody I know is taking medicine, but how would you steer your career into the world of space medicine?
Yeah, what I did, I started to work in Berlin in the Center of Space Medicine when I was 26 years old, and I thought it's a really nice idea to start off with this. It was my first postdoc job, and then you just get to know people, and at some stage you can just start to do your own research by putting in proposals for announcements of opportunity or solicitations of the big space agencies. So the European Space Agency, for example, solicits opportunities every year. So they've just solicited research in Antarctica or on the space station, or last year they had 2 bed rest studies, and then we just put in proposals. So we're quite independent. I work with a group of people from different countries in the world, and we've kind of collected in 2011, so 10 years ago, and I've known them for quite a while now, and we've had experiments and a lot of ESA studies now, and that's how we do it. So you don't have to work in a space agency. You can just work anywhere in academia, basically, to be part of the community.
That is so cool. Wow. Okay. So when was the last time you two saw each other then, by the way?
2 years ago.
No.
Oh, yeah.
It's nearly time to see each other then,
isn't it? When the pandemic
started,
I withdrew to the forest, and well,
I'm coming in August. I'm coming. Yeah, right. I've booked flights. It's all set.
I'll be there.
Nice. For that. There is the Finnish satellite workshop happening, and I think sign up is free. So if anybody's interested in watching online, Google for, I think, Space Workshop Wi-Fi.
That sounds.
And I will give a talk there. So they've invited me to give a talk there on space medicine.
That is so cool.
And there's plenty of things about engineering, about satellite design, about solar panels. All these kind of things are going to be there.
Okay, so just before we go then, and thank you so much. It's been a wonderful interview. Apologies for your internet, Urs, but these things happen when you live in a little log cabin by a beautiful lake. You can't have everything. I, for my dinner, have just had exceptionally high quality butterflied king prawn curry. It was really, really good, cooked in coconut milk and beautiful Malaysian spices. Now, we were talking earlier about shrimp cocktail on the ISS and the story of how their taste buds changed. Tell us a little bit more about how the shrimp cocktail on board the space station is
do you want to do that?
currency.
If my internet allows,
please do.
If my internet allowed, I'm going to try this. Gita can fill in if it gaps out again. So as we've heard before already, once fluid shifts in body, all the fluid from your legs goes up to your head, and your taste buds swell up among many other physiological reactions, and that means it's sense of taste changes your rarity. Some things you really like on Earth you can't stand anymore, and other things you really abhor are suddenly the best treat ever. And there's one item on the menu for astronauts that they can pick to be delivered to the space station. That is the shrimp cocktail, produced apparently by NASA in Houston, where it's a local Galaxy, which, so we've been told by astronauts, most astronauts really abhor. It's horrible when you eat it on the ground. But once you're in space, it's apparently the most delicious thing ever. The point that it has become something like the unofficial currency on board the International Space Station. Astronauts tell stories how they trade it for favors, or they trade shrimp cocktail with the Russians, because the Russians, even though not officially, do have vodka on the space station. And then So that's what's being brought up. And we have the recipe for that cocktail in our book. So if you're interested in that,
if you want to
the
make a
book.
horrible shrimp cocktail, then you've got to read the book.
It
Bob,
might be horrible.
You don't have to buy the paper book. You can just buy the ebook, Bob. Come on.
Come on, Bob.
Come on. Buy the ebook.
Please do. So give the book one last plug. I'll let you go full screen us again and let us talk.
Right.
Just show the cover of the book, please. Check him out. There we go.
Beyond Earth.
Excellent. Okay, so let's go back to the three of us. There we go. That's the one. Right. It's been a pleasure. And maybe in a couple of months, I'd love to have you back on, maybe when we've all got better internet and we can talk even more about your fields of expertise, because space medicine and supercomputer aurora research is like, wow, that's what Pop Astro Live is made of. So thank you very much.
Thanks for having us. It's been a great pleasure. And
bye.
If you have questions later, just drop us a message. Yeah,
that'll be wonderful, and we'll pass them on. Thank you so much. Oh yeah, there you go. I can do that. I can also do that. Oh, that was my trick. I'll see you all later. Bye. Bye us. Thank you. They stole my trick. Right, popular astronomers. Where are we down to on the running list? That was such a great interview. We could have spoke all night about them. So what Urs was saying, and it was a bit of a poor connection, is that the shrimp cocktail, which I think is prawn cocktail in English, tastes grim down on the earth, but there's something about it that happens to your taste buds. They change when you're in space that make it the most irresistible dish to the point where it almost becomes currency on the ISS. So yeah, there you go. That's what you got look forward to. Thank you. So I'm just having a look at the comments here. Yeah, we're talking about favorite sci-fi films. I don't watch sci-fi. I don't watch any film. I do not have the attention span to watch to watch a sci-fi film or any film. I barely have got enough attention span to watch a tweet. So this is a real endeavor for me doing this. So what we're going to do now is we're going to go over to Eleni, and while Eleni is talking, I'm going to attempt to get the photographic paper out of my solar can, take the photograph, send it over to Ian, who's going to process it. Oh no, it's going to take too long. It's going to take too long. Ian, we're going to have a go anyway. We'll see what we can do. So, excellent interview. Yes, it was good. Are you ready, Eleni? We're coming. Hello.
Hi, everyone.
Eleni, we love you. How are you?
Guys, I'm okay. I had a bit of a long, tough week at school, as usual.
Aww.
Them kids.
Do they love you like we do, or do they misbehave?
No, they're awful. But I made an impact when the eclipse was around, and somehow 2 girls went and got the special glasses and came to me the day after and were like, Miss, we watched the eclipse because you told us about it. So that kind of made up a little bit for the misery of the previous day.
That's such a shame. That's such a shame. Okay. Process. Okay, right. So what we're going to do, Eleni, take your time with the report tonight. I've got to cut a piece of paper out of a can and send it over to Ian, who's going to process it here, Ian Baker, and send it back so we can have the solar can image live on air. Okay.
Oh, there you go. Ian says it's going to be quick, the processing. So
right. I just need to get the instructions and remove it in the dark. So take as long as you want with this report. You can take as long as you want. Go into detail. Go into detail, go off-piste, go off-piste, do a dance, do some yoga, do whatever you want, stand on your head again.
I don't think it's going to take you that long. I think you've got this.
I don't know what I've got to do. I think it's stuck and I've got to take a photograph of it with weird light conditions. So we're going to go, all right.
Okay, let's see how much I can stretch 5 slides.
We'll throw you into a black hole and make time stretch out, Eleni.
I don't want that.
Okay, we'll not do that. Right, we can see you and we can hear you. So the stage is...
Right. I can't believe like I'm still struggling every time to figure out what I need to press to get into the slideshow. Okay, we're here. So, okay, I will try to stretch this one out as much as I can without becoming annoying. So I'm going to start with quite an interesting observation, and it's got to do with protoplanetary disks. And I think that's really exciting because we want to know how planets are made, and we want to know how they link with their stars, if at all. And this study is basically telling us that they do. Now, to give you a little bit of context, the study is focused on data from 500 young stars with protoplanetary disks around them. And the data was taken by ALMA, the Atacama Large Millimeter Array. And it's a very extended, if you want, study. So the sources were studied in depth. And it's actually, it was out on, what was 23rd? Was that Tuesday? It was out on Tuesday. It was published on Tuesday. And they found, the scientists that work with those 500 young stars, found that there is a direct link between the mass of the star and whether or not it's going to form more Jupiter-like planets or more Earth rocky-like planets. And it's all got to do with these gaps. I'm not so sure if they are very obvious in this image. I will get my brightness up a little bit more. That's as high as it goes, but hopefully you can see that there are gaps here. So what the data shows is that if you have a high mass star, you're more likely to get a setup of a protoplanetary disk that looks like this one here, where basically you have the disk extending outwards from the star, and you have these gaps forming, and these gaps are due to planets that have a mass between the mass of Neptune and the mass of Jupiter. So we are looking at Jovian-like planets and gas giants. So the study shows that high mass stars correlates highly with Jovian planets. Then you can have this type of planetary disk. So this is all the three different types you can have, basically. And here we're looking at a larger than Jupiter planet, a super Jovian planet, which basically has created this donut shape in the disk. It does look like a donut a little bit. And then you have this type here, where you do not have anything as heavy as Jupiter. So basically, you cannot see any gaps, and it's a very pedestrian planetary disk, if you want. So why is that important? Why do we care? Well, we do care because this is basically a way to look back in time and see how a young star of a certain mass gets the planets that it gets later on in its life. And if you know the mass of the star, then you can gauge whether or not it's going to have a system, a planetary system, mostly made up of Jovian planets or mostly made up of rocky Earth-like planets. And this correlation, this link, works both ways. So high mass stars implies gas giants, whereas low mass stars implies actually rocky planets. And this can work very well for exoplanet research, because it gives an opportunity to scientists to know exactly what type of stars to look for, what type of stars to target when they want to search for rocky Earth-type planets. So this is quite a big observation, I think, that we have found this direct link between the mass of the star and the protoplanetary disk. And hopefully I have convinced you too that it's an important part of astronomy research. And I'm going to take you now from maybe the not so interesting looking protoplanetary disks to something that I think is actually pretty cool. So I think it was in the news in Greece as well, because I think my dad was telling me about it. So it must have been in the news. So it made the news. So that's pretty big, right? So we're looking at a cosmic hand hitting a wall. Okay, it's not quite like that, but it looks like that.
Eleni, I've never once interrupted your broadcast, but that is amazing.
It is, isn't it? It's spectacular. Look at that. It does look like a hand. It looks like it's got like the sinew here and the fingers, and like that looks like a nail as well, you know, like when you open your hand like that. It's crazy.
That's excellent.
I know it is. And also, what an incredible coincidence to be able to get such a shot, right? Because this is amazing. Now, a little bit of background, of course, the data comes to us from Chandra, which is an X-ray observatory. And here we are looking at a composite. So we're looking at a supernova blast plus the X-ray nebula, which is basically particles that have been blown outwards from the pulsar that is left behind after a supernova explosion. And we're looking at that traveling at a speed of humble 9 million miles per hour, colliding with a gas wall, basically. So you can imagine that there is a surrounding gas, which is basically probably wrapping, if you want, the area that the supernova is traveling in. And then eventually what we have is the blast wave moving outwards, and at some point it's hitting that wall of gas. And in doing that, it's ionizing the gas. So it's imparting some of its energy to that gas, that wall of gas. And this is what we see here in this inset. Now, I have also tried to put that in the next slide a little bit bigger, but I'm not so sure if it's going to play. So we'll try this and see if it works. So what we get here is actually a composite from 2004, 2008, and 2018. And what you see, if I play it, it's hopefully should play. Yay, it played. Okay. So what we see is actually, if I slow this down a bit, I can't slow it down, but basically it's the shockwave traveling, so it's the blast traveling through that gas wall, if you want. And if I go back to the other slide, yeah, that's a bit better. You can see that in time, and we're talking about the blink of an eye here, these times are nothing in a cosmic time scale. So we can see how, if we focus on a spot, say we pick this area here, you can see how it actually gets a little bit dimmer as time goes on. And that's because this is a very dense gas wall. And what's happening is that this blast wave is struggling to push through. And in its effort to push through, it's losing some of its energy. And we're looking at something that's also really dense, which will affect how bright it looks. And it's actually, I think, one of the most violent observations of the universe up to date, like how energetic it can be, and the events that take place, and the amounts of energy that we're talking about, and the speeds we're talking about, and the fact that we can actually see that in almost real time, not quite, of course. I think that's really amazing. Now, this supernova was probably visible here on Earth 1700 years ago.
Oh wow!
Yeah, I know, right? So it's been a while, and I think the fact that we can actually, see things like that today shows how far we've come. It's incredible. And I thought it was worth sharing with you. And I'm really glad that the video played as well, because I was worried that it wouldn't play.
I think that's one of the biggest miracles of modern technology, is that you managed to make a video play on this software, Eleni. So well done.
Yes. Okay. What do I get? Do I get anything special? Do I get chocolate? That's my bribe.
Oh, I've had a delicious bag of Galaxy minstrels tonight. They were lovely.
See, I love a Galaxy bar, but the smaller, the minstrels ones, I find them odd to eat. I don't know why.
Well, you probably weren't brought up on them like I was, weaned on them. So, what's your chocolate of choice, please, Eleni? And I will send you a lorry load of it.
I can go two ways. I can go a Kinder chocolate. Yeah. Kinder Egg even better, because I like the surprises. And or a bar of Galaxy, and then I'm happy.
Oh, I'll remember that. Kinder Egg or Galaxy. Excellent. Right. Great.
I have 2 more slides.
Yeah, go for it. Are you
getting closer to opening your can?
It's come back already. I'll disappear off, and then we can look at the picture together.
Perfect.
Okay.
So here we have space news and weather. I'm afraid we don't have any auroras, but that's because this lovely sunspot here has actually been very quiet, and it seems to be stable so far. And unfortunately, we don't have any beautiful northern lights to look upon, because this little fellow is stable. So maybe it will wake up in a few days. Maybe we will be lucky. But I still think that this picture, this image of the sun, which is taken today, by the way, it's today's image of the sun, is pretty incredible. So aurora or not, I think it's pretty incredible. And we're coming to my last slide. As promised, this is the astronomy picture of the day. And this is the galaxy very imaginatively called Messier 99. I know astronomers sometimes struggle with names, but what can you do? And I think it's a very beautiful picture of a galaxy. Now, as I said, as I promised, with this astronomy picture of the day, I'm going to be giving a little bit of astronomy background and tidbits of info. Now, we're looking at what we call a spiral galaxy, and you can very clearly see the beautiful spiral arms here and here. And this is a composite image. It's looking at 3 wavelengths. So we have UV, ultraviolet, sorry, I shouldn't use contractions. So ultraviolet, visible, and infrared data, all combined courtesy of Hubble, of course, always Hubble telescope. And we are looking at one of the face-on spiral galaxies. And this is a good opportunity to quickly mention that there are 3 broad categories of galaxies. They're very broad because there are sub categories in there, but we usually have elliptical galaxies, which are not particularly impressive. They just look like elliptical blobs. And then we have spiral galaxies, which look beautiful, like this one. And then we have irregular galaxies, which look a bit like scrambled eggs, on the frying pan, just all over the place. And we have this type of spiral galaxy, and then we have the Milky Way type of spiral galaxy, which seems to have a T bar in the center. So I already brought up the 2 subcategories of spirals. But if you want to know more about galaxy classification, you can always drop a comment on Facebook, and I will do my best to reply. I think I reply to everyone's questions and comments. If it takes me a while, apologies, but usually after the show I rush to have food, because I'm a person that cannot, I'm not doing well if I don't have food like almost 24/7. So if I take a while, bear with me. It's because I'm eating, and then I'll come back and answer any questions you've put on the on the chat.
So, Eleni, I didn't mean to gate crash into your presentation. In fact, make that go away. I've got something to do first. That shouldn't have come up then. The wonderful screen share technology. First of all, we need to rewind about 10 minutes because I forgot to play your song and I'm determined I'm going to play it for you.
No.
So, here's Eleni's song.
Let's do it.
Here she is with the space news. It's Eleni. It's Eleni. Prepare to be astonished by Eleni. By Eleni. When she's not reading Tolkien or teaching a class, she's doing yoga and toning up a PowerPoint presentation for astronomer emulation.
I forgot
Never
my
gets
music.
old.
I forgot my
Never gets
music. There we go, Eleni. So, thank you for that wonderful presentation. I love the hand high-fiving the universe. Phew, wonderful.
Incredible.
That was
you can
so good.
connect with it if you try.
That was so good. So good.
It was.
Okay, so Cosmo's theme now. Cosmo is a
Where is
rogue
Cosmo?
sloth. He's here. He's here. He's right at the end of the show.
There we
This is-
go.
If you are new to the show, Cosmo is the abandoned telescope sloth. He hangs off my telescope and currently been garroted by some tinsel. Cosmo's got a theme tune, and then we're going to have Cosmo's guessing game, and then we're going to go to the pinhole camera results. Okay, Eleni. So hang around with me for a minute. Okay.
Perfect.
I know you're really hungry. Are you too hungry to stay for 5 minutes?
No, I can definitely do 5 minutes. I really want to see that picture now. the
Okay,
pinhole
here it
camera
comes.
picture.
Right, where's Cosmo's song? There he is.
He's been flying around the solar system, or maybe a bit further.
But to the casual observer, he's a mithering, pestering sloth.
Where have you been to this week, Cosmo? Cosmo, where have you been?
3 clues. Only answer after the clues. Cosmo over and out. So little Cosmo, young Cosmo here, goes flying off around the... Is he in the solar system? Yes, he's in the solar system this week. And I'm going to read out 3 clues. It's a brain teaser, not fastest finger first. So try to wait until I've read out all 3 clues. That's just like me exerting a tiny little bit of power over you. The only bit of power I appear to have in my life at the minute. You will wait until I've read out the 3 clues. Otherwise, me and Paul Sutherland will get angry. So I'm going to actually put the clues in the banner here because it's a bit difficult to say and to spell. So let's have a look.
Now I am intrigued.
Okay. Show. Okay. So Cosmo has been doing algebra. It's more like a crossword clue, Eleni. X marks the spot. And he's hanging there with his friend Claire Obscure. They're your only clues. 2 clues. It's a bit cryptic. So while I leave that on the screen, it's a cryptic one tonight, isn't it, Cosmo? Off you go. We're going to have a look at the picture. Okay, so I am not sure whether I have done this right. Ian Baker, our wonderful SPA member, has processed it for us. And looking at it, I don't think we've positioned our camera right because it's lopped off the, I would say, probably most of summer. But are you ready for it? So basically, what happens is the solar can, it's in the wardrobe now, away from the light. It's a solar can pinhole camera. It's been up in our back garden for 6 months. It's been tracing the line of the sun. It comes out on a piece of photographic paper. You've got to take a picture of it or scan it and then invert the image, which is what Ian has done, the photographic processing. It's beautiful. It's lovely. Are you ready for it?
Really want to see it. Yeah.
Dun, dun, dun. It's got my blue thumbs at the bottom. That's it.
Oh, wow.
It's great, isn't it?
This is amazing.
Yeah. Unfortunately, it's lopped off midsummer, but I am assuming that it's the dark bits that are the sun. Or is it the light bits? Which way round is it, Eleni, do you think?
Would probably say the dark bits, but I'm not sure either.
It's got to be the light bits because it's photographic paper, is it? Oh, but it's
Is
inverted.
it not a negative?
It's inverted. Which way round is it?
I'm really not sure. I don't know.
Somebody help. Because I know that you can see where we had Wales had its wettest spring on record, and we had lots of cloud. So I'm assuming that kind of like dark bit towards the top is where we had lots and lots of cloud, inverted, so black. Is the sun black or is the cloud black? Me and Eleni can't work it out. Which way round is the sun? Anyway, either which way, you can see where we've had sunny days and cloudy days, and you can definitely see midwinter's day right down at the bottom. And look at the difference of the sun's path between summer and winter.
That's pretty amazing.
It's really good, isn't it? And the funny thing is, can you see my two thumbs holding the paper?
I think I can. Yes, that's down to the left and right, bottom left and bottom right.
Oh, hang on. He sent me a second one. Okay, Ian, let's have a look. He's done me another one. Oh, look at that, Ian. So Ian has, look at the second one to see the sun. That one had extra color processing. So the light bit is going to be the sun, isn't it? That makes sense, surely. Or is it the black bit? Help! The light bit to the sun. Sean, I'm going to just go with the light bit to the sun. It has to be, of course, doesn't it? Otherwise, it would be weird. So, yeah, you can see midwinter going up. And look at how, no wonder it gets hot in summer.
Pretty.
What would a solar can at the equator look like, Eleni? Would it just be a stripe that went straight up?
Probably, I think. Or relatively straightish, like... You know, I don't think it would be completely straight, but it would be the next best thing, like a very light thing like that, maybe.
I'm wondering what a solar can at the equator would look like. I'd be very interested to know. And next time we have Sam on, Sam Solar Can, who we had on last week, that would be great if you could tell us. So the light bits are the sun. Thank you. Oh, okay. So, Eleni, do you know where Cosmo's been? Can you hazard a guess?
No, I've been trying to think, but I really suck at this kind of.
Yeah, I do as well. It's horrible.
Yeah.
I can't do anagrams. I can't play Scrabble.
It may come to me when I'm like lying down in bed and not thinking about it, but now I'm like, my brain is thinking omelette and stuff.
Lovely omelette, galaxy omelettes. I like that. Did you say that galaxies are like scrambled eggs?
Like irregular galaxies, yeah, they're like a little bit all over the place. So it's like when you do your scrambled eggs and they just don't have a perfect shape, they're just a little bit all over. That's how I think, irregular galaxies look a little bit like that.
That's a lovely way of putting it, actually. Okay, so Cosmo has been doing algebra. X marks the spot, and he's hanging around there with his flair clair obscure. That's your only clue. Okay, and David Hargreaves has got it right. Well done. Now, I don't know whether you've ever seen the Lunar X, Eleni. Have you seen it?
Nope.
I'm going to read what it is. It's kind of like an optical illusion in which light and shadow creates the appearance of the letter X on the rim of 4 craters, Blanchinus, Lecae, and Purbach, and another one. It's only visible for a few hours before the first quarter. And you know what, Eleni, if you've got a good telescope, it's so exciting to see. It's really, really exciting. And it's like a little algebraic X. It's not that kind of X. It's a curly one because it's made by the
I overthought about it way too much, I was thinking X marks the spot. So, and then I was clair obscure. I was thinking obscure. Maybe something to do with dark in Latin. Clair also means light in Latin. I was so confused. Overthought the shit out of it.
Okay, so Eleni, it's a beautiful effect, and you'll have to Google it, and it's really, really good. And we saw it once with Macclesfield Astronomy Group. Hi, Mac Astro and Co. And Malk, astronomy lecturer, and we had a holiday in Anglesey to see it, and we were so excited. You'd have thought we were watching a total eclipse. It's really, really exciting to see if you can get a chance. Okay, really popular astronomers, please share the video. It's been wonderful to have you along. I think my internet's been okay. No one's complained about it, so that's a good start, Eleni.
It's been good.
Yay! Yeah. We have gone to all sorts. Now, the thing is, the internet men, I've sent them basically a begging email this week explaining how much of this show depends on good internet, and They're either going to be upping our bandwidth and giving us new hardware. So there is time yet for my life to be saved.
Nice.
Very good. Okay, we're going to go now. Thank you, everybody, for joining in with the show. Urs and Bergita, that was so exciting. Space medicine and supercomputers in Northern Lights.
Incredible people. Their interview was just amazing.
Oh, so good.
So knowledgeable.
Yes, they were. Jim, thank you yet again. Thank you for your lovely comments, Jim, and your participation. Cannot wait for the next show. Now, I've been informed that there might be something like 70, maybe even more, 70 hours of Pop Astro Live to binge watch. Right from the early days when we didn't have a backdrop, we didn't have an Eleni, we didn't have a Cosmo, and I didn't have a clue, right through to now. This behemoth of broadcasting that it has become. Sonia's going away for a hot tub weekend, Steve, and well noticed that she's not here. And David says good night. Oh, it's lovely. We've got some lovely loyal followers. It's so nice, Eleni. Isn't it lovely?
Some really nice comments, yeah.
Yeah. Oh, thank you, everybody.
Thank you, everyone.
I'm going to press the off button now and say goodbye. Share the thing, and I'll just have a quick chat with you off air. Okay.
Perfect.
Thanks for your help, Ian, with the lovely photographic paper. It was lovely. Thank you. Bye.
Bye.